Voyager 1, launched more than 40 years ago, continues to astonish us with discoveries far beyond its original purpose. When it first left Earth in 1977, its mission was simple by today's standards: to fly past Jupiter and Saturn, take close-up images, and study their moons, rings, and magnetic fields. At the time, engineers expected the spacecraft to last only about 5 years. Few could have imagined that more than 4 decades later, Voyager 1 would still be active, billions of kilometers away, sending back data from a realm no spacecraft had ever entered. What makes Voyager 1 remarkable is not just its longevity, but the way it keeps reshaping our understanding of the cosmos. Among its most surprising revelations came when it detected 300 mysterious objects adrift in deep space. These objects, likely plasma clouds left behind by ancient stellar explosions, appear to be fragments of stars that died long ago. They float silently across the galaxy, carrying the history of creation and destruction within them. Studying these remnants may help scientists understand how material is recycled through space, how the ashes of old stars become the building blocks of new ones. Voyager's journey became historic in August 2012, when it crossed the heliopause, the invisible boundary where the solar wind of our Sun gives way to the thin gases of interstellar space. Crossing that frontier marked the first time a human-made object truly entered the space between the stars. It was an achievement that symbolized both the limits of technology and the boundless curiosity of humankind. But survival in interstellar space is no simple task. Voyager 1 is powered by 3 radioisotope thermoelectric generators. They do not rely on sunlight, which would be far too faint at such distances, but instead use the heat from the slow radioactive decay of plutonium-238. This heat is converted into electricity, powering the probe's instruments and transmitters. Yet as decades have passed, the power supply has steadily weakened. To keep the mission alive, engineers have carefully turned off non-essential systems one by one, cameras, heaters, and scientific tools, so that core instruments can continue operating as long as possible. Communication with Earth has also become increasingly difficult. A signal from Voyager 1 now takes over 21 hours to travel across the void, and the reply takes just as long to return. By the time engineers send a command and see the result, nearly 2 days have passed. Its faint transmissions, competing against the background hum of the universe, are captured by NASA's global network of giant radio antennas, known as the Deep Space Network. Every message that arrives is weaker than a whisper, but it carries priceless information about regions humanity has never seen. In recent years, Voyager 1 presented engineers with a new puzzle. Data coming back from the spacecraft suddenly appeared scrambled, as though corrupted by interference. For months, the team painstakingly tested each system, reviewed decades-old blueprints, and ran simulations. Finally, they discovered the culprit. The spacecraft's attitude and articulation control system had begun routing information through a long-dormant computer that had not been used in decades. The fix was delicate. Every command had to be carefully written, then sent across space, where it would take nearly 22 hours to arrive. Weeks later, after patient troubleshooting, normal data flow was restored. This episode highlighted something extraordinary. A spacecraft built with 1970s technology, still functional in an environment harsher than any laboratory on Earth, can be repaired and managed across nearly 23 billion kilometers of space. It demonstrated the patience, skill, and determination of the engineers who continued to guide Voyager 1 more than a generation after its launch. Even as its power diminishes, the probe continues to return valuable data. The discovery of plasma remnants is more than a curiosity. It is a window into the grand cycle of stellar life and death. By studying the properties of these plasma clouds, researchers hope to understand how galaxies evolve, how matter is distributed through interstellar space, and ultimately, how solar systems like our own are born. Each transmission from Voyager 1 is a fragile signal. Voyager's mission, however, is not only about science, it carries with it something far more profound. On board, sealed within a protective case, is the golden record. This copper disc is unlike any other artifact we have ever sent into space. It contains greetings in 55 human languages, music from around the world, classical pieces, traditional folk songs, and even early rock and roll, alongside the natural sounds of our planet, the crash of ocean waves, the rumble of thunder, the chirping of birds, and the gentle cry of a newborn child. In essence, it is a capsule of human existence, a message in a bottle cast into the cosmic sea. The golden record is more than a technological curiosity. It is a statement about who we are. It shows that humanity is not only capable of exploration and science, but also of creativity, empathy, and hope. It declares that when we venture beyond our world, we bring with us not just instruments and machines, but our cultures, our stories, and our dreams. Even if no one ever finds Voyager, the record remains a symbol, an offering from a small planet to the vast unknown, proof that we once looked up at the stars and longed to connect. Yet, as timeless as its message may be, Voyager 1 itself is bound by limits. Its power comes from a slowly decaying source, and by the end of this decade, most of its instruments will fall silent. By 2030, the spacecraft will no longer be able to send us data. Its voice, which has spoken across billions of kilometers for more than half a century, will fade into silence. When that day comes, humanity will lose its most distant active probe, but the mission will not truly end. Voyager 1 will keep going. Long after our antennas can no longer hear it, the spacecraft will drift silently through the galaxy. It will wander among the stars for billions of years, far longer than Earth itself may survive. In this way, Voyager becomes more than a machine, it becomes a monument. It will outlive mountains, rivers, and perhaps even our civilizations. Long after future generations have come and gone, it will remain, carrying the story of humanity into eternity. This endurance gives Voyager 1 a unique place in history. It reminds us that exploration is not simply about discovery. It is about persistence, about the willingness to reach for the unknown even when the outcome is uncertain. Voyager 1 was not built with modern supercomputers or advanced propulsion systems. It is powered by the technology of the 1970s, yet it has traveled farther than any machine in human history. Its very existence proves that persistence, patience, and vision can achieve the extraordinary. Each faint transmission from Voyager is more than just data, it is a whisper across the void, a reminder of our collective determination. It tells us that curiosity is one of humanity's greatest strengths. It shows that even a fragile spacecraft, no larger than a car, can expand the boundaries of human knowledge and inspire the imagination of generations. When we reflect on Voyager 1, we see not only the success of a mission, but the reflection of ourselves. It is a mirror of human ambition, showing that we are a species that dares to venture outward, to ask questions, to dream of the stars. And as it drifts deeper into the galaxy, Voyager carries a message more powerful than any single discovery. We were here, we dared to explore, and we sent our story into the stars.